Now the next method to find the root is the Newton Raphson method. Here we are going to find a root with the help of tangent, with the help of draw the tangents. So how we will exactly going to find the root? Let's find out. So here what we are going to do essentially, let me come to the screen. We will make a initial guess x naught, and from here we will pick the value of the function. So this is the f of x, this is x, and this is our initial guess x naught. So corresponding function value will be fx naught, let's say, and from here we will draw the tangent and we will see the root of the tangent where it actually intersects the x-axis. So this is the root of the tangent where it actually intersects the x-axis, and this point will be our x1, and from x1 we'll again pick the value of the function, that is fx1. This is the fx1, and from this point we will again draw the tangent and we will get another point or another root of that particular tangent. Let's say this is number 2 tangent, this is number 1 tangent. Another point we will get the value x2, and from here we will repeat the procedure and we again draw the tangent and we will find the point x3, and we are keep on drawing the tangents till we approach towards our solution, that is our root of the particular polynomial. So this is the method. So this is the graphical representation of the Newton Raphson method. So what we are actually going to do, we will represent it in mathematical equations form. So how we can write in the mathematical equation form? We need to write the equation of that particular tangent. So this tangent, let's say I'm writing the equation of particular tangent 1. So there are two ways. You can directly use y is equal to mx plus c, or you can use the Taylor series to write the equation of the line. This is the equation of the line simply. So if I use the Taylor series, so let's say this is initial guess is x0 and x1 is equal to x0 plus h. So if I need to calculate f of x1, then it will be f of x0 plus h upon factorial 1 plus into f dash x0, right, plus higher order terms. So I'm neglecting these higher order terms. Now this is the value of x1. What is the h? H is here x1 minus x0. So let us put that value. F of x1 is equal to f of x0 plus x1 minus x0 f dash x0. But remember, our target is to find the root of that particular line. So the root means the function value is 0. Here the function value is 0. So this will be the 0, f of x0 plus x1 minus x0 f dash x0. So now in the next step we will determine the value of x1. So value of x1 from this equation will be x1 is equal to x0 x0 and minus of f of x0 upon f dash x0. So this is the value of x1. Similarly, if you need to calculate x2, then x2 will be x1 minus f of x1 upon f dash x1. In general, if you want to calculate xn plus 1, then it will be xn minus f of xn upon f dash xn. So we will keep on repeating this process till we reach at particular point, which is called a root of that equation, root of particular equation. Remember, in this case, the equation should be continuous and it should be differentiable. Otherwise, you will not get the correct solution. So we are keep on searching the points from the initial guess through the drawing the tangents. So this is essentially the procedure. In the next step, what we will do, we will actually code it in the C++. So we will code it in the C++ in the next lecture, how to write the code for the Newton Raphson method. In the next lecture, we will see that. Thank you.